It's lecture 8.3. It should be our final video on risk and return. So we ended up on this screen at the end of the last video. We were talking about the CAPM, or the capital asset pricing model, and beta. Beta is a measure of non-diversifiable risks. So we just got done talking about diversification and how you can lower your standard deviation without lowering your expected return by diversifying. Beta. Let's talk about beta. It's a measure of non-diversifiable risk. There's two special betas, and everything else is measured relative to these two special betas. For example, the zero beta. If you have an asset with a beta of 0, that means it's the risk-free asset. 0 stands for no risk. You have no non-diversifiable risk. Then we have another special beta, which is 1, which refers to a fully diversified portfolio. So it needs to be, it's a proxy. We pick some portfolio that's easy to get access to. For example, the entire U.S. stock market is usually what we use. That's why we call it the market portfolio, because it's the whole market. So we usually pick something like the S&P 500, the Dow Jones Industrial Average, the Wilshire 5000, something like that. Some proxy that exists out there for the entire market. If it's the entire market, it holds a whole bunch of stocks, thousands of stocks, or in the case of the S&P 500, 500 stocks. But those are the 500 biggest stocks, and so they account for the majority of the market. Even though it's only 500 stocks, it's probably closer to like 80% of the total market capitalization of the U.S. stock market. So it holds basically the whole market. Same thing with the Dow Jones. Dow Jones is only 30 stocks, but they're the 30 biggest stocks out there, and so they account for a large portion of the whole market. If you have that whole market portfolio, we call that our fully diversified portfolio, meaning it shouldn't have any non-diversifiable risk in it, and we call that a beta of 1. Everything else's beta is measured relative to that. So if you have a beta of 0.5, that means you're halfway between fully diversified portfolio and 0 risk-free asset. Here's a look at the actual capital asset pricing model. It's a linear formula. It's got a, we call it a one-factor model, because really the only factor in it is the market. It says the return on I, that's the return on I is some individual security, some individual asset, equals the risk-free rate plus its beta, it's the beta of I, times what we call the market risk premium. That's what the return on the market would be. So the one factor really is the market portfolio, the fully diversified portfolio. Actually has two factors, because it has the risk-free rate and the market portfolio. The market risk premium is actually, you can break it down into, it's the return on the market minus the risk-free rate. So it's the return the market made over and above what you could have got by taking 0 risk. So it's also called the security market line, because this is a line. If you remember back to your algebra classes that you've probably had in the past, you can describe a line, y equals mx plus b is a standard way that they write it, where m is the slope and b is the intercept. Well, that's basically what we have here. Your market risk premium is your slope of the line, and the risk-free rate's the intercept. You can see that line graphed out here. Just keep scrolling down. Slow scroller. In your textbook, they actually graph out the security market line. So it's, again, it's a blue line. It's not unlike the blue line I showed you over here. It's actually pretty similar. It's slightly different. It's not exactly the same thing, but it shows you a trade-off between risk and return, except this one has beta on the x-axis. So for a given beta, it tells you how much return you should get, and it's upward sloping line, because you take more beta, you take more risk, you get more return. Note here, if we plug our two special betas in, we should get what we think we should get. For example, if we plug in a beta of 0, that's the risk-free asset, no systematic risk. Put a 0 in for beta, this whole term cancels out and you get the risk-free rate. Well, that's what you should get, right? Risk-free 0 beta should get the risk-free return. If you plug in a beta of 1, you should get the market return, and you do. So put a 1 in here for beta, and then it's basically risk-free plus return on the market minus risk-free. The risk-frees cancel out, and you're just left with return on the market, and that's, of course, what you should get. Everything else, any other asset, is going to be a return somewhere relative to how much beta they have. Plug in a 1 beta, you get return on market. Plug in 0, you get risk-free. Plug in 2 beta, you're going to get a return that's out further on that blue line, so you're going to get a higher return because you're taking more risk. Okay, we need to talk about how to actually calculate beta. That would be the next thing to look at. I'm going to flip back over to my Excel spreadsheet. And here I have some returns for 2 different assets. Let me make this a little smaller so it's easier to see. The blue line represents a fully diversified portfolio. That's the US stock market. I think I actually used the S&P 500 index this time on this one. The red line represents an individual security that we want to calculate the beta for. In this case, I've used Coca-Cola. KO is the ticker symbol for Coca-Cola. So for starters, notice that they are correlated, meaning a lot of the times when the market goes up, Coca-Cola also goes up, and when the market goes down, Coke, but they're not perfectly correlated. There's definitely times where the market's gone way up and Coke hasn't gone way up. Okay, so as long as they're not perfectly correlated, there's diversification benefits. We want to say, all right, if we account for all those diversification benefits, how much risk is left over? And that's called our beta. The beta calculation actually comes from the, I'm going to go ahead and delete that now. That was just to show you what the 2 stock charts look at, give you an idea. But if we go back and look at the capital asset pricing formula equation, looks like this. Again, this is a line, and so one way to calculate that beta is a regression. A regression is a statistical tool where you can estimate a slope and an intercept. If we regress returns on the market versus returns on our individual security, it will tell us the slope of that line, which is beta. That's basically how you calculate beta. So let's do that. If I go back over here to my spreadsheet, I've turned these lines, these were logarithmic scale returns over time. What I did was I converted them into actual day-to-day returns, which is I took the natural log. Actually, since it's sort of a logarithmic scale, I just took the difference. So what I've done is convert them. If I scroll over and look at this chart, this is much harder to read, right, because it's daily return. So sometimes it spikes up, that means the stock went up that many percent that particular day. Sometimes it's down, that means the stock went down that particular percent. But it's hard to look at this line and understand what's going on. That's why we usually look at it like this, because it's easier to see over time exactly what's happening. But when you're going to calculate the beta, you actually have to work with daily returns, not with the stock chart, but with the daily returns. So I have my daily returns here, and now I want to fit a line to that data. The way we do that is you can fit a thing called a scatter plot, which is I'm going to grab these 2 lines. I grab the first line, which was the market returns, and then I hit Control. Oh, I actually screwed it up. Got to do it again. So I grab the market returns, and I hit Control, and I grab the other returns. And then let me pull my spreadsheet down so you can see up here. I go to Insert, and then I want to insert a scatter plot. Let's just do it as dots. All right, now I'm going to go ahead and put this back up here so we don't have as much wasted space up there. This is a scatter plot which I haven't formatted yet because I just made it, but on the x-axis is returns that the market had. It goes as x, y. So the one on the left is your x-axis, the one on the right is your y-axis. And so I have returns on the market and returns on Coca-Cola. So if you just pick a given day, that means the market returned that much if we're at this dot right here, and Coca-Cola returned that much on that day. If this is a nice vertically sloping up collection of dots, that means they're correlated. That means when one goes up, the other goes up, and when one goes down, the other goes down. To figure out exactly how well those 2 are related, we actually want to find the slope if you were to fit a line to that group of data. So I go Add Trend Line. I right-clicked and said Add Trend Line. There's lots of different trend lines you can add. One's called linear. That's what we want here. And then I want it to display the equation on the chart so that we can actually see what that slope is. It fits a line to that data, and it puts an equation up here. So I'm going to make it a little bigger so we can read better. And that's our beta right there. 0.7596 is the beta over that time period. This is about a 6-month time period. So there's different choices you have to make when you're using the CAPM and calculating betas. How long a time period do you want to use? Do you want to use daily returns, weekly returns, monthly returns, things like that? Those are all kind of minute details. Hopefully, regardless of what you choose to put in there, if you pick 6 months or 3 months, if you pick daily returns weekly, you come up with about the same number. And most of the time, just from experience doing this, that's true. But again, this is just a one-factor model. We're looking at how Coke moves relative to one factor, which is relative to a fully diversified portfolio, which is the market portfolio. And it tells us that if we have a 0.7596, so we have about a 0.76 beta. That means if the market goes up 10% in a given period, we would expect Coke to go up about 7.6%. If the market goes down 10%, and that's relative to the risk-free rate, but that's not that big a deal. If the market goes down 10%, we would expect Coke to go down about 7.6%. So it's telling you, on average, how does it move relative to the market. And what that does is it kicks out all the noise, which is all the stuff that could be diversified away, basically. Without getting into the real detailed math, when I got my PhD, I had to go through and prove mathematically that the capital asset pricing model works. I'm not going to make you do that in this class, but just take my word for it. What it does is it kicks out all the noise. It kicks out all the movements in Coca-Cola that could have been diversified away. And it's saying only the 7.6 is non-diversifiable, or 0.76, meaning that on average, market goes up, fully diversified portfolio goes up 10%, Coke goes up about 0.76 times that. So that's how you actually calculate a beta. You're not going to have to calculate a beta by hand in this class. There actually is a formula for it if you want to go look it up. It's, and I didn't put it in the notes just because I don't even think it's in your textbook. I can put it in here real quick. Let me pause this video. I'm going to type it in and then I'll restart the video. Alright, so I just in the video you didn't see it obviously because I paused it, but what I actually did was pause the video, typed out this formula, and then restarted the video. So the beta for a given stock is actually a factor of two things. This is the slope of any regression line, so it's actually not unique to the beta calculation. It's unique to how we calculate a regression line, how we calculate the slope in a regression line. But it's a factor of their relative standard deviations. So it's the standard deviation of the individual stock divided by the standard deviation of the market. So standard deviation does play a role into beta. If a particular stock is more volatile, so it has bigger swings in the market, it's got to have a bigger beta. But then there's another factor in there, and that's the correlation of the two assets. So it's the correlation of I, our individual stock, and the market, the fully diversified portfolio. The smaller that correlation is, the smaller beta is going to be because there's more diversification benefits. If that correlation happens to be 1, which means it's perfectly correlated with the market, which would be rare, but it's possible, then it's truly just a factor of their two standard deviations. But if that correlation is anything less than 1, there's some diversification benefits and this beta gets smaller. So that's how we calculate beta. So as I mentioned earlier, I'm not actually going to make you calculate beta, but I will make you use the capital asset pricing model. If we go back up and look at the capital asset pricing model, it looks like this. It's basically algebra work. I'm going to actually let you kind of figure this part out on your own in your assignment. So I'm going to let you do a little bit of problem solving. But usually what happens is you're given a certain number of these variables and you have to solve for the other one. So maybe you're given beta and you're given the risk-free and you're given the return on the market, and you got to solve for that beta, what would be that particular stock's expected return. Just plug them all in and solve. Sometimes you're given a different subset. So maybe you're given the expected return and given beta and given the risk-free, and you got to figure out what's the expected return on the market. Then you just got to do a little bit of algebra, rearrange the equation, solve for the other one. But your latest quiz that's been posted, I think it's quiz 7, you'll be doing that, and so you'll get some practice. Note on those quizzes, you can save them, you can turn it in as many times as you want. So they're not intended for you to lose points. Keep trying them until you figure out how to get the right answer, and if you really can't figure it out, send me an email or post a question on the discussion board, or even call me and I'll try to help you through it. Alright, we're out of time on this.